Hello and welcome to Unit 1.1 Video 6 for Mr. McGee's 9th grade biology class at Arizona School for the Arts. This video series follows the biology coloring book by Robert D. Griffin. In this video, we're going to take a look at the molecular structure of water and unusual properties of water. Before we begin, I'd like you to pause the video and just take a few minutes to review some important ideas. I'd like you to review valence electrons and their effect on reactivity, hydrogen bonds and where you find them, what happens to ionic bonds in water, and how covalent bonds form. This diagram shows the creation of water molecules from oxygen and hydrogen. On the left, you'll notice that each of the two hydrogen atoms has only one valence electron, while the oxygen atom has 6. You'll remember that hydrogen needs to have 2 valence electrons to be stable, and oxygen needs to have 8. By sharing their valence electrons, hydrogen and oxygen can both become more stable because their valence shells will be full. However, because the oxygen atom has a nucleus with more protons than the hydrogen atom, the electrons in the molecule tend to spend more time around the nucleus of the oxygen atom. This creates a difference in charge on either side of the molecule. The sides of the molecule where the hydrogen are has a partial positive charge because the electrons are not there as much as they are around the oxygen. The side of the molecule that has the oxygen atom will have a partial negative charge because the electrons spend more time around that part of the atom. This causes H-bonds, which makes water molecules stick together and in some cases stick to the surfaces of their environment. H-bonds are responsible for almost all of the unusual properties that water has. Here's a list of 8 unusual properties of water that we'll take a look at. I'll let you read them to yourself if you need to, or you can write them down in your notes. The first property of water is that it's a good solvent. Water can dissolve more substances than any other known solvent. This includes salts, sugars, proteins, gases, hormones, and many other substances. Here's an example of how this works. Remember that sodium chloride is an ionic compound that we know of as table salt. Remember how we talked about that table salt will dissolve easily in water. It does this because the sodium ions have a positive charge, and they can be separated from the other molecules in the salt and surrounded by molecules of water. Notice how all of the water molecules are arranged so that the negative oxygen end of the water molecule faces the positively charged sodium ion. The chlorine ions, on the other hand, have a negative charge, but water can separate and surround them just as easily. It does this by surrounding the chlorine ion with the ends of the molecule that have the partially positively charged hydrogen side. Specific heat or heat capacity is a property of many substances. It's a measure of how much heat energy it takes to change the temperature of a substance. Temperature is a measure of the kinetic energy of the particles of the substance. This basically means that heat energy causes particles to move faster. Water molecules tend to resist moving faster. Why do you think that is? High specific heat is a property of water that tells us that it needs to absorb a lot of energy before changing its temperature. This is why your pool will still feel cool despite the fact that the temperature during the summer may reach 110 degrees. Hydrogen bonds hold water molecules close together, so it takes more energy to speed them up. Water also has a high heat of vaporization. Heat of vaporization is the amount of energy needed to turn liquid water into water vapor. Why do you think it would take more energy to evaporate water than some other liquid? Well, it has to do with H-bonds again. The H-bonds prevent water molecules from separating. So heat energy must overcome the H-bonds before a molecule can escape. This means it takes a lot of heat to cause water to become a vapor. Water also has a high heat of fusion. This means that a lot of heat must be removed from water for it to freeze. As a result, water freezes slowly. Capillary action is another property of water. Water is easily drawn into small tubes or cracks or crevices. H-bonds cause the water molecules to become sticky, and then the water molecules are pulled into the small safe spaces of capillaries or cracks and crevices by the attraction of the water molecule to the surface. Water also has a high surface tension. The surface of water acts like a membrane or a skin. This is because H-bonds pull the molecules of water together and resist their separation. Water expands on freezing. Water molecules do this because in order to freeze into a solid, they must assume an orderly arrangement. This occurs because each positive end of a water molecule must be near the negative end of another water molecule. As a result, the orderly arrangement of the water molecules in ice take up more space than they would as a liquid. In your science notebook, I'd like you to list each property of water and give at least one example that demonstrates how that property of water is beneficial to living things. You'll have to do your best to brainstorm here and think outside of the box. I'll give you an example. Remember that water has a high specific heat, and that's important for living things because it makes homeostasis possible. Notice that this bullfrog not only lives in the water, but each of the cells of its body is mostly full of water. If water were to change temperatures too quickly, this bullfrog would not be able to maintain a constant internal temperature, and so would be likely to die from changes in the environment. Well, that's the end of this video. Please complete the corresponding review questions and be prepared to show notes to me in class. Thanks, and have a great day.